Hi guys, welcome back to Algebra 2. Today we're going to be talking about 2-3, the factored form of a quadratic function. And so what are we going to be doing today? Well, first, we're going to be using, now I've written these in different order, but we're going to look at how I can use factoring to solve a quadratic equation and inequalities. So how can I use the skills that I got last class to solve equations and then inequalities? Then we'll look at what does the factored form tell me about a graph of a parabola. And then finally, how can I write the equation of a parabola that's written in factored form? So let's recap what you have learned so far just a little bit. I would encourage you to look, we're on page 76 in your workbook. I would encourage you to look at this question maybe in your own time and kind of explore what's going on in the scenario here. But we have three different students. So Corey wrote an equation in factored form, and then let's see, Kimberly wrote an equation like this, and then Joshua wrote an equation here. Now, you are probably recognizing Joshua's form as the vertex form. And then you might also recognize Kimberly's form as the standard form. Well, what you see with Corey is the factored form. So these are the three different ways you can write a quadratic function, and then it have like a special name. So you can write a quadratic function in either vertex form, factored form, or standard form. Now the question on this page asks you to explore the function that each of these three students wrote and ask you a couple questions about that. So it could be interesting for you to look into. But let's get going on some of these examples. So first of all, I said we're going to talk about how you can use factoring and how you can use it to solve equations. So let's review some factoring here. On example 1, where we have to factor the expression, I see that there are two terms. Since there are two terms, I'm going to see if this is a special case. And I notice that x squared is a perfect square, and 9 is also a perfect square. So I recognize that this is a difference of squares. And you can factor a difference of squares into two binomials by taking the square root of the first, x and x, the square root of x squared is x, and taking the square root of the last, the square root of 9 is 3, so 3 and 3, and then have a plus and a minus. Then the next one, I notice that there are three terms. And first I'm looking to see if there's a greatest common factor between 3, 7, and 2, and I'm not seeing any. So then I'm going to try my guess and check method. So I'm going to set up two sets of parentheses. And then I'm going to try to see, are there any, what multiplies to be 3? Well, 3 and 1, so 3x and x. And what multiplies to be 2? Nothing but 2 and 1. So then I'll see if the product of 2x, 2 times x and 3x times 1 will add or subtract to be 7. So let's see, 2 times x is 2x, 3x times 1 is 3x. Can I add or subtract 2x and 3x to get negative 7? Nope. So we're going to try switching the 2 and the 1. So switch places. Let's put a 1 here and a 2 there. Now let's check. 1 times x is 1x. 3x times 2 is 6x. And I can combine 1x and 6x if they're both negative to be negative 7. So then my factorization here, if I erase that part, is 3x minus 1 times x minus 2. So that's a little review of last time. So now we're going to come back to example 2 in a second, but let's look at example 3. Because example 3 says solve quadratic equations by factoring. And so you notice I have an equal sign here. It's not an expression anymore. I'm actually trying to figure out what x is. So here are some steps on how to solve by factoring. All right, step 1. You need to write the equation in standard form and let it equal 0. So you're going to rewrite the equation in this form. Rewrite, and I'm going to abbreviate EQ as equation in ax squared plus bx plus c equals 0. We're going to rewrite it in that form. So we're going to move everything over so that it equals 0. So that means for me on part A, I need to subtract 20 on both sides. So now I have x squared plus 8x minus 20 equals 0. So step 1, done. Step 2, we're going to factor, in this case, the left side. Okay, so I'm going to factor x squared plus 8x minus 20. Always bring down the equal 0. To get x squared, I'll multiply x by x. To get negative 20, let's see, maybe a 10 and 2. 10 times 2 is 20. And then let me check the products. That would be 10x. X times 2 is 2x. To get positive 8, I need to subtract the 2, so I'm going to follow this and make that minus 2 plus 10. Now, I don't need those lines there, so I'm going to subtract. Okay, so it's factored on the left side. Now, step 3 is to apply something called the zero product property. Now, the zero product property says if two numbers multiply to be 0, then either the A equals 0 or B equals 0 or both equal 0. Because the only way that you can multiply and get 0 is if one of the factors or both of them are 0. So when we're solving for x, we're trying to find all the possibilities. And right now, I have a binomial times another binomial saying that it's equaling 0. So either x plus 10 equals 0 or x minus 2 equals 0 or both. And so we're going to act like it could be both. So because I'm trying to find all possible answers here. So x plus 10, to solve that, I would subtract 10 on both sides. So x would be negative 10. And for x minus 2 equals 0, add 2 to both sides, and we get x equals positive 2. So my two possible solutions are x equals negative 10 and x equals 2. Now if I want to check, and I'm doing some temporary work, so I'm going to erase it in just a minute. If I want to check, then I would substitute negative 10 in for the x in my original problem. So my original problem is x squared plus 8x equals 20. So I'm going to see if negative 10 will make this true. So it's negative 10 squared plus 8 times negative 10. Is that equal to 20? Let's see, that's 100 minus 80. Does that equal 20? Yes. So x equals negative 10 is correct. Okay, then I'm going to check by substituting in 2 for x. So is 2 squared plus 8 times 2 equal to 20? That would be 4 plus 16. And that does equal 20. So yes, x equals 2 is also correct. So you can check to make sure that you got the right answer doing that. I can also do part B, but if you feel like you understand 3a, you can skip ahead in the video. Let's see. So part B, I'm going to write the equation in ax squared plus bx equals plus c equals 0. So I'm going to move. Let's see. I'm going to subtract 3x, subtract the 2, so that I have. Whoa, that's a highlighter. I need the pen. So subtract 3x, subtract the 2 on both sides. So I'll have 2x squared minus 3x minus 2 equals 0. Now I'm going to factor the left side. So factor 2x and x are the only way I can multiply to get 2. And again, the only way I can multiply to get 2 are with 2 again. So I'm looking ahead, I'm thinking I need 3. So let's see, that's 4x, 1x. If I make the negative 4 negative and 1 positive, that will give me negative 3. So I'll erase these marks right here. Then I'm going to apply the zero product property. 2x plus 1 equals 0. X minus 2 equals 0. So with the x minus 2, if you add 2 to both sides, we get that x equals 2. And then if I subtract 1 on both sides, I get 2x equals negative 1. Divide both sides by negative 2, x equals negative 1/2. Okay, now let's talk about how the factored form is going to help me actually see things in the formula. So here's the graph. Example 2, relate the factors to zeros of a function. So the graph shows the function y equals x squared minus 9x minus 20. We have to identify the zeros of the function, and then how do the zeros relate to the factor? Okay, so if you're like, wait, what are zeros? Let's define those real quick. Let's grab the black. Okay, so the zeros of a function. I'm going to abbreviate function fn. So the zeros of a function are the x values that correspond to the y values that equal 0. In other words, on the graph, they're seen as x-intercepts. So if you can see the x-intercepts on a graph, you can see the graph, the zeros. They're the same thing. Another way to think of them are the number, the x value, for which f of that value, so if you put that number in for the x, you're going to get 0. So in other words, the x that gives the y value 0, the x-intercept. You'll also hear these called roots, zeros, intercepts. You can think of them, you'll find them all in the same place on the graph. All right, so how do the zeros relate to the factors of x squared minus 9x plus 20? Well, let's find the zeros first. I have a 0 and x-intercept right here and right there. So let's see, I've got one at 4, 0, and then another one at 5, 0. So if I take the function y equals x squared minus 9x plus 20, and I factor it, so I'm writing this function in factored form. So x times x is x squared, two numbers that multiply to be 20. I'm thinking 5 and 4, and if you make them both negative, you'll get negative 9. Okay, so if you look there at the factored form, and then you look at the intercepts, notice you see something really similar, right? You see a 4 and a minus 4 and a 5 and a minus 5. Well, the factored form shows you the x-intercept. So that's why the factored form is helpful. So the factored form shows you the x-intercepts or the roots. Same thing. So I think it would be helpful if at the top of your notes that was listed instead of like kind of hidden. So like by example 1, let's make a space that says factored form. So the factored form is written as y equals a times x minus p times x minus q. And you're like, wait, what's that a? Okay, so the p and q are the x-intercepts. And notice when they're in the parentheses, we have to take the opposite of them. Whoops. So the p and q, that's an and symbol, p and q are the x-intercepts. And a, that a value is the same a from the vertex form and standard form. As vertex form and standard. So why is the factored form important? Because you can look at it and you can tell what the x-intercepts are. So keeping that in mind, let's skip down to example 5, where it says determine positive or negative intervals of a function. So we have the function y equals x squared minus 4x minus 20, and we're wanting to determine where this is negative. So it would be helpful if we had a graph. And so what I'm going to do is I'm going to factor this. So if I change this into factored form, change to factored form. Then I'll have y equals, let's factor this, x, to get x squared we need an x and an x. To get 21 I can have 7 times 3 is 21 with a negative 7 and a plus 3. Alright, so that's factored form, and because it's in factored form I can look at these numbers and tell you what the x-intercepts are. So there are x-intercepts at 7, 0, because you take the opposite of the symbol in there, and negative 3, 0. So from that information, I'm going to sketch a graph of this parabola. So at negative 3, 1, 2, negative 3, and then at 7, 1, 2, 3, 4, 5, 6, 7. It's a rough sketch. Negative 3, there's an x-intercept at 7. Now, is my parabola going to open up or is it going to open down? Well, I look and see that the a value is positive. And since a is positive, my parabola opens up. So, oh, and look, I can also tell the y-intercept. The y-intercept is negative 21. So I'm going to say, oh, let's just say that's negative 21 down there. Okay. So, no, I don't know where the vertex is. So the vertex could be that negative 21, but I doubt it because it's not quite in the middle. So maybe I should redraw that because it probably goes a little bit further. Maybe it looks more like that. Okay, but what I'm trying to answer is the intervals where the function is negative. So remember, negative means where the y values, the graph where the y values has negative values. So that would be all the parts below the x-axis. So that would be everything from x equals negative 3, or maybe I should say between x equals negative 3 and x equals 7. And so if I want to say between it but not including, I would see everything from negative 3 to 7, including that. Okay, let's see. Example 6, write the equation of a parabola in factored form which passes through the point 1, 2. Okay, so we need to write the equation in factored form. So the first thing I'm going to do is I'm going to start with the factored form. And the factored form is y equals a times x minus p times x minus q. Okay? Then I'm going to, so let me come over here and let me write that in. Y equals a, x minus p, x minus q. Okay, then I am going to, number 2, substitute in the zeros or the x-intercepts for the p and the q. So y equals a times x minus, now my first x-intercept is 3, and my second x-intercept is negative 3. So x plus 3. X minus 3, x plus 3. Then I need to figure out the value of a. I don't know it. So this is similar to what you did with vertex form where you had to find the a value. Same idea, it's just now we're working with factored form. So I'm going to substitute in, abbreviate substitute sub, in the point 1, 2 for x and y to find the a. So y equal, not y, I'm substituting in for y. I'm going to substitute in 2 for y. 2 equals a times 1 minus 3 times 1 plus 3. I'm going to have to come over here and continue. Then I'm going to simplify. So 2 equals a, 1 minus 3 is negative 2, 1 plus 3 is 4. So 2 equals a, negative 2 times 4 is negative 8. So let me write this as negative 8a. Then I'll divide both sides by negative 8. And I get that a equals negative 1/4. Okay, so I've found a. Yay! Yay, I found a! All right, step 4, I'm going to write my equation with a, p, and q all substituted in, because whenever you write your equation in factored form, you're going to substitute a number for the a, number for the p, and a number for the q. So my equation is y equals negative 1/4 times x minus 3 times x plus 3. That's the equation in factored form. And because it's in factored form, you're not asked to graph it, but why not? I can give a sketch. I know that there's an x-intercept at 3. I know there's another x-intercept at negative 3. I know it opens down, so I can do a quick little sketch, and that will help me answer the question. All right, and then we did not answer this part, so we can mark it out. Okay, now finally, we have a word problem. I was saving it for last because I know you guys love those word problems. All right, example 4 says a baseball is thrown from the upper deck of a stadium 128 feet above the ground. The function h of x equals negative 16x squared plus 32x plus 128 gives the height of the ball x seconds after it is thrown. How long will it take the ball to reach the ground? Okay, well, the first thing we want to do is we want to figure out what x stands for and what y stands for. So x is going to represent what? Let's see, does it tell me x seconds? So that tells me that x is time, and time in seconds. Y, in other words, h of x, is, let's see, the function gives the height. So that is height in terms of feet. All right, so when it says how long, what this is saying is what is x, because it says how long, which is time, will it take the ball to reach the ground? Well, when the ball's on the ground, its height is 0. So they're asking what is x when y equals 0. Now I'm going to need to erase this other space that I was getting in. So that's what I'm trying to answer. So knowing that is what they're asking me, I can write this equation as 0 equals negative 16x squared plus 32x plus 128. Now I put 0 because it said the height would be 0. So I replace the y with 0. Now I'm going to try to solve for x because I'm asked what is x. So I'm going to try to solve by factoring. I'm going to look for a greatest common factor. I notice that all three of these coefficients can be divided by negative 16. So I'm going to factor out a negative 16. When I divide all three by negative 16, negative 16x squared divided by negative 16 is x squared. 32x divided by negative 16 is negative 2x. And 128 divided by negative 16 is negative 8. So then I'll try to factor the trinomial. 0 equals negative 16. To get negative 8, I might do a 4 times a 2. And if the 4 is negative and the 2 is positive, then I can get that negative 2x in the middle. All right, so now let's apply the zero product property. I'm going to set each factor equal to 0. So when I set the first factor equal to 0, negative 16, is negative 16 ever equal to 0? No. So don't worry about that part. Then I'm going to set the second factor equal to 0. X minus 4 equals 0, which is going to tell me that x would be 4 seconds. Okay? Cool. Let's see what happens with x plus 2. If I set x plus 2 equal to 0, then x would equal negative 2 seconds. Well, in this scenario, it does not make sense for me to have a negative amount of seconds because I cannot go backwards in time. So I'll mark that one out. So it looks like this problem only has one correct answer. So how long will it take the ball to reach the ground? It will take 4 seconds for the ball to reach the ground. Oh, we'll lift out the word the ground. Don't need that there. All right, so that concludes section 2-3.